We're going to take a quick review at the exponent laws and add a couple new ones that you may not have seen before. With the exponents, recall that when we're working with exponents or powers, we also use the term powers with exponents, we're just looking at repeated multiplication. So you could say something like 2 raised to the exponent 5, 2 to the power of 5. We could write it 2 with the little 5 up top. That's the exponent or power portion. And then 2 times 2 times 2 times 2 times 2. Those are all the same thing. They all mean we are multiplying 2 by itself 5 times. The exponent tells us how many times we are or how many factors we're multiplying. So 1, 2, 3, 4, 5 factors that are being multiplied. So for example, 3 to the 4 is 3 times 3 times 3 times 3. Notice it's 4 times. 5 to the 6. 1, 2, 3, 4, 5, 6. 5 is being multiplied together. 3 to the 2. 1, 2. 3 is being multiplied together. And 4 to the 0 is 1. Now you might not be aware of that one, but we're going to take a look at that in a moment as we look at our laws. So the laws you should be familiar with are the multiplication and division and power of a power laws. The multiplication law says that if we have an exponent or 2 exponents with the same base and we multiply them, we just add the exponent. So that is m plus n there. Okay, it might not be clear on the screen there. So for example, if we have 3 squared times 3 to the 3, well, 3 squared is 3 times 3. 3 cubed is 3 times 3 times 3. So that is 1, 2, 3, 4, 5 3's being multiplied together. 2 plus 3. So we add the exponents and we get 3 to the 5. That's the same as 3 times 2, 3 to the 2 times 3 to the 3. So we're just adding the exponents. In the case of division, it's converse and we subtract the exponents. So a to the m over a to the n is a to the m minus n. So here we have 3 to the 4 divided by 3 to the 2. So I have 1, 2, 3, 4 3's over 2 3's. These pairs will cancel, and we're just left with 3 times 3, which is 4 minus 2, or 3 to the 2. In the case where we have a to the m to the n, so when we take a power and put it to a power, we just multiply the numbers, both exponents. So 3 to the 2, well, that's 3 to the 3 right there, 3 3's. Another 3 3's, so there's the squared. Thus, we have 1, 2, 3, 4, 5, 6. 3 to the 3 times 3 to the 3. 3 times 3 times 2, is 6. And there we get our example. Now, earlier I said that 4 to the 0 is equal to 1. Well, the general rule is that a to the 0, anything to the 0 is equal to 1. Here's the reason why. If I have 3 to the 4 and I divide it by 3 to the 4, I would have 3 to the 3, or 4 3's over 4 3's. They would all cancel. I'm left with 1 over 1 or just 1. We also know that it's subtraction from our subtraction rule, so 4 minus 4 is 0. So the 1 is the same as 3 to the 0. There's an example of that. In the case of fractions, if you have a over b to the power of m, it's the same as a to the m over b to the m. And we expand out 2 over 3 here. We have 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. So to the power of 4, so 4 times. But multiplication, we multiply the top numbers and we multiply the bottom numbers. So we're multiplying 2 by itself 4 times. We're multiplying 3 by itself 4 times. So that exponent just gets spread across both of the numerator and denominator. And finally, we have that a to the negative m is the same as 1 over a to the m. So you can just take the reciprocal and get rid of the negative sign. Here, as an example, if I have 3 to the 2 divided by 3 to the 4, well, I got 1 2 on top, 1 2 3 4 on bottom. So those pairs of 3 cancel, and we're left with 1 on top and 3 squared on the bottom. That there relates back to our subtraction or division, and so we have 2 minus 4, which is negative 2. So 1 over 3 to the 2 is the same as 3 to the negative 2. That's it. A couple examples here to take a look at just to work with the exponent laws. And then you can try some practice type problems. We have negative 8, a to the 5 times 2, a to the 3 squared. So we got to deal with the squared first. So I got negative 8, a to the 5, and then we square each component. We have 2 squared, which is 4, and then 3 times 2 here using our multiplication exponent law. Our power of a power exponent law. So we have a to the 6. Now I just multiply these out. I multiply the numbers together. Negative 32 multiply a to the 5 times a to the 6, and I get my total of a to the 11. Because again, we're adding the exponents. In the next case, we're dividing. So we divide each component. 12 divided by 4 is going to give me 3. K to the 2 divided by k, that's just going to give me a k. 2 minus 1. And finally, m to the 8 divided by m to the 5. So that's going to leave me with m to the 3. And so I get 3km cubed. The final question here. So order of operations would say do the brackets first. So do everything inside the brackets here, and then we'll do the exponent next. But the exponent's 0, so it doesn't matter what the inside of the brackets are. Anything to the power of 0 is going to be 1. We don't have to do any extra work there because everything inside here is going to be nullified by that power of 0.